Hello again. We are back with some more parabola work, quadratic equations, and this time we are going to talk about quadratics in intercept form. So this is the third form from this unit. This is Unit 2, Lesson 3, and in the first lesson we studied parabolas and specifically in vertex form, and then in Lesson 2 we studied parabolas specifically in general form. And now our last form is parabolas or quadratics in intercept form. So an intercept form means it has been fully factored. So you can immediately see your two factors here. And remember, factors are also known as x-intercepts. So factors are x-intercepts. Sometimes we call them solutions because it's when it sets the equation equal to 0 because you want y to be 0 because it's the place where the graph crosses the x-axis. So all of these things are related to factors right here. So P and Q would be factors, right? If we use the zero product property, then we would solve for x and we would get our x-intercepts. So let's try it. Example 1. It says sketch the graph of y equals x plus 5 times x minus 1. Now, sometimes we have an a value in front. Well, we always have an a value in front, except this time it's invisible. It's an invisible 1. So your a value is 1, which means it doesn't have any special stretch or shrink. We didn't reflect it. So we're just going to jump right into finding those x-intercepts. So either x plus 5 is going to equal 0, or x minus 1 is going to equal 0, because essentially I'm setting y equal to 0 so that I could find my x-intercepts. So my two x-intercepts are negative 5 and 1. So I immediately know that my parabola is going to cross through the x-axis at negative 5 and 1 because those are the x-intercepts. Now, if we have to graph the rest of this parabola and we need at least 5 points on the graph of the parabola, then how do I find a few other key points? Well, hopefully you're saying to yourself a really key point that we must have is our vertex, because your vertex is either your maximum or your minimum. Now, if you have a positive leading coefficient of 1, that means the parabola is opening upward, which means this particular parabola is going to have a minimum. So where is your minimum going to be? Well, your minimum is going to be where your axis of symmetry is. So how do I find my axis of symmetry? Well, hopefully, let's just pause and think about that for a minute. If I have x-intercepts at negative 5 and 1, where would my axis of symmetry be located? Well, hopefully you just had a little moment and you're like, well, I got that. That's just going to be right smack in between the two x-intercepts, right? Your vertex has to be on your axis of symmetry, and your axis of symmetry has to be right in the middle of the two x-intercepts. Okay, what key word did I say there? I said middle, in the middle of the x-intercepts. What is another word for middle? It's average. So if I take the average of the x-intercepts, then I'm going to get the axis of symmetry. So remember, the axis of symmetry is a vertical line, so I'm going to set x equals negative 5 plus 1 is negative 4, negative 4 divided by 2 is negative 2, and you can see I put that axis of symmetry right here at x equals negative 2. So my axis of symmetry is x equals negative 2. Now, what does that really tell me? The only thing that tells me is that my vertex, the x-coordinate of my vertex, is now going to be negative 2. The question is, what is the y-coordinate of my vertex? Well, go back to your original equation, which is y equals x plus 5 times x minus 1. And now I'm trying to solve for y if x equals negative 2. Right? If my x-coordinate in my vertex has to be negative 2, I'm just going to substitute in. So I would get y equals, and I would put in negative 2 plus 5 and negative 2 minus 1. So what do I get? I get 3 times negative 3. So my y-coordinate of my vertex is negative 9. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry for counting. And then there is a point, another point on this parabola. But remember, I said we need 5 points on our parabola. So how can I get 2 other points? Well, if I have now that I have my vertex, if I have a stretch value of 1, there is no stretch factor. That means I would go to the right one, up 1, left 1, up 1, or right 2, up 1, 2, 3, 4, left 2, up 1, 2, 3, 4, and then right 3, up 9, because 3 squared is 9. And so this here is an accurate, fairly accurate drawing of our parabola. So what did we do? We used the x-intercepts, located the points where the graph is going to cross the x-axis. We took the average of the x-intercepts so that we could get the x-intercept of the vertex, or we located the axis of symmetry, which is also the same x value as the vertex. Then I plugged that x value into the original equation to get my y value of my vertex, and then I have my vertex and my 2 x-intercepts. I used my 1 to 1, 2 to 4, right, relationship to graph because I had a stretch value of 1, and then that is how I got the graph of my parabola. Please talk to a teacher if you're not sure. Always ask questions if this didn't make any sense. Okay, so here's a problem where you might want to pause and just try it on your own. It's going to be a little bit messier. I mean, you're going to have fraction answers because we have this stretch value here of negative 1/3. So it's negative and it's a fraction. So you might have numbers that aren't perfect whole numbers, but that's okay. Don't be afraid of fractions. Go ahead and embrace them and go for it. If you want to go with me, you can do that. Otherwise, pause and try it on your own. So your x-intercepts. Your x-intercepts we get by trying to make these 2 parentheses 0. So I know that my one x-intercept is negative 3 and one x-intercept is positive 5. How do I know that? Because either x plus 3 equals 0 or x minus 5 equals 0. So x equals negative 3, 1, 2, 3. I graph that, and x equals 5, 1, 2, 3, 4, 5. So there are 2 of my x-intercepts, or 2 points on the parabola. Now, how would I find the axis of symmetry? I would do that by taking the average of the 2 x-intercepts. Remember, your axis of symmetry has to be right smack in the middle. You can count blocks, 1, 2, 3, 4, 1, 2, 3, 4, or we can just say negative 3 plus 5 divided by 2 equals 2 divided by 2 equals 1. So my axis of symmetry is 1. The axis of symmetry, that means my vertex is going to be some number, right? So your axis of symmetry also is the same x value as the vertex. So now I need to plug 1 into my original function. So I have negative 1/3. I'm going to plug in 1 for x. I'm going to plug in 1 for x. So I have 1 plus 3, 1 minus 5. And now I just do the math. So it equals negative 1/3 times 4 times negative 4. Well, 4 times negative 4 is negative 16. Negative 16 times negative 1/3. We just multiply straight across, so that's 16/3. 16/3, I don't know, where is that on the graph? Well, I'm going to change that into 5 and 1/3. So my y coordinate of my vertex is 5 and 1/3. So I go to the right one, up 1, 2, 3, 4, 5, and yes, we're just going to approximate. So it's just going to be floating up there right above 5. Now, we need 5 points on our parabola. So in order to graph the parabola, we're going to ask for 5 points on that graph. It's going to say that in the instructions, so right here it says that. So because you have a 1/3, that's a little messy, so you might want to go with the y-intercept to help you graph the parabola. Here we specifically asked you for the y-intercept, so the y-intercept is when x equals 0. So we're trying to find the y-intercept, which is f of x, and we find that by making x equal to 0. So I get 0 plus 3, which is 3, 0 minus 5, which is negative 5, and 3 times negative 5 is negative 15, and negative 1/3 times negative 15 is 5. So my y-intercept is 0, 5. And so I go up 5. Now remember, a parabola is symmetric, so if it goes through 0, 5, it must go through 2, 5, because it's equidistant from that vertex. So if I connect to these 5 points, because now I have 5 points, ooh, that's not a very pretty parabola, sorry. Here is a sketch of my parabola. I had my y-intercept, and then it's a symmetric or reflection across the axis of symmetry, and then I have my 2 x-intercepts, and I have my vertex. So there are my 5 points. Lastly, it says rewrite the equation in general form. General form is ax squared plus bx plus c. So all we're going to do is we're going to take that equation and we're just going to expand it. Right? So f of x equals negative 1/3 times x plus 3 times x minus 5. Well, first you want to take x plus 3 times x minus 5 and expand that, and then distribute the 1/3. So remember, you're going to FOIL first, outside, inside, last. I get x squared minus 5x plus 3x, which is negative 2x, and then 3 times negative 5, which is negative 15. Then I go ahead and distribute my negative 1/3. Sorry, I'm running out of room. So general form would be negative 1/3 x squared plus 2/3 x plus 5, because negative 1/3 times negative 15 is positive 5. So that is general form. Again, it's kind of weird talking to this. It's hard to explain it. If you're not understanding, please ask questions to your classmates, to your peers, or to your teacher. Moving right along. Let's look at this example about a startled cat. So a startled cat jumps into the air, and its height above ground in inches with respect to time in seconds can be modeled by the function h of t equals negative 2t times t minus 3. So I'm visual. I'm going to immediately jump to a graph here. I know that my x-axis is time in seconds because t is over here as my input value, and I can see that my y-axis is height, h of t. Sorry, that's really messy right there. I'm going to redo that. Trying to find the eraser. So this is my height, h of t, and that is going to be in inches. So what do we know? Well, immediately I'm looking at the x-intercepts. It's already in factored form, so h of t equals negative 2t times t minus 3. So I either have negative 2t equals to 0, so t equals 0, so it's 1, 0, or I have t minus 3 equals to 0, so t equals 3, so that's another 0. So I know that the parabola representing the cat's height over time looks something like this. So this is just your general equation, right? And there's a maximum height that your cat is going to be on, and the maximum is, of course, the vertex of the parabola. So let's look at the questions now. It says, how high is the cat after 0.5 seconds? Well, we're just going to put in 1/2 for t. So it's negative 2 times 1/2 times t, oh sorry, not t, apologies, times 1/2 minus 3. If you want to put in 0.5, that's fine. Negative 2 times 1/2 is negative 1, and 1/2 minus 3 is negative 2.5, or negative 2.5, and negative times negative is positive, so that would be 2.5 seconds. Or sorry, my bad, it's late. 2.5 inches. So the cat was 2.5 inches in the air after 0.5 seconds. Okay, so if this is 3 seconds, what's right smack in the middle? If I'm going to my graph over here, this is 1.5 seconds. So then if we cut that into thirds, that's 1 second, this is 0.5 seconds. So we're saying this height here is about 2.5 inches. If I'm just kind of doing my best guesses here, just approximating. All right, so it says, how long is the cat in the air? So how long is the cat in the air? So this graph over here is representing time and height, the height of the cat in the air over time. So the cat is at 0 inches at 0 seconds. It jumps in the air, it's up in the air, and in the air, and in the air until it gets back down to a height of 0. So how many seconds was the cat in the air? Oh dear, 3 seconds. Wow. That is a special cat if it can stay in the air for 3 seconds. 1, 2, 3. That cat must have been really, really scared. Then it says, how high does the cat jump? Well, we're going to, hopefully you're saying to yourself, oh, that means I've got to find the vertex. So I just said earlier, well, that axis of symmetry is halfway in between, or the x-coordinate of the vertex is 1.5. So now I need to find the y-coordinate of the vertex. How can I do that? I'm just going to plug in 1.5 into the equation. It's negative 2 times 1.5 times 1.5 minus 3. I like to change that into fractions. So 2 times 3/2 is just negative 3, because negative times positive is negative, and then 3/2 minus 3, that's 1.5 minus 3, which is negative 1.5, or just negative 3/2. So that's positive 9/2, which is 4.5. So the cat jumped in the air a total height of 4.5 inches. Okay, so the cat was in the air. Think of how short 4.5 inches is. Oh my goodness, this problem is quite unusual. Can a cat only jump 4.5 inches in the air and stay in the air for 3 seconds? Okay, we'll see. Ask your science teacher. I don't think that's possible. Moving right along, I would say go ahead and pause here. This is just another look at the same idea. So pause. Try this one on your own. See how you do. All right, did you get 2x squared minus 2x minus 12? If not, then I'll try to explain what happened here. So first of all, we have two zeros, or x-intercepts at negative 2, 0, and 3, 0. So that turns into x plus 2 times x minus 3. But remember, we have our a value. We don't know what the stretch value is. So we need a point on the parabola in order to find the a value. So here's the point. It's the y-intercept. So what does y-intercept mean? That means it's when x is 0, y is going to be negative 12. So I plug in negative 12 for y and 0 for x. I'm just using this function right here. And so I get negative 12 equals 0 plus 2, which is 2, 0 minus 3, which is negative 3, and negative 2 times negative 3 is negative 6. I divide by negative 6 and get a equals 2. Then I plug that back in for my a, like I did here. But notice it says write your final answer in standard form. We meant general form there, and general form is when you multiply it all out. So what do we have to do? First, you need to expand x plus 2 times x minus 3 to get x squared minus x minus 6. Then I distribute my 2 through those to get my final answer of 2x squared minus 2x minus 12. Okay, this is another one that you should definitely pause and try it on your own. So you might think, oh, wait a minute, what do I do here? I have x minus 2 times x minus 2. That's correct. So you have what we call a double root, right? So when it only goes through x minus 2 twice, we call it a double root, or that root has a multiplicity of 2. So the x-intercept is 2, 0. So if the root is the same twice, then that means that is your axis of symmetry, and that is where the vertex is located. So the the axis of symmetry is x equals 2, and the vertex is 2 comma something. So how do we find that something? Well, it actually just has to be that point. So it's just 2, 0. right? So how would we figure that out? Well, you would say f of 2 equals 2 times 2 minus 0, or sorry, 2 minus 2 times 2 minus 2. I'm plugging into this equation up here. That's just 2 times 0, which is just 0. So that has to be the vertex. The double root has to be the vertex. Okay, what is the y-intercept? The y-intercept is when x equals 0. So I'm trying to find the y-intercept, which is also f of x, when x is 0. So that's 0 minus 2 times 0 minus 2. Negative 2 times negative 2 is 4. 4 times 2 is 8. So my y-intercept is at positive 8. Now, again, if we have, so my y-intercept is 0, 8. If we have our axis of symmetry here at x equals 2, and we know parabolas are symmetric, then if it goes through 2 units to the left and up here to 8, we're going to go 2 units to the right and up here to 8, and that is another point on this parabola. Then you also might notice that you have a stretch factor because we need to have 5 points on the parabola. We're always going to ask you for 5 points. So we need to get 2 more points. And so with that stretch factor of 2, we would go right 1 up 2, left 1 up 2. We used to go 1 to 1, 2 to 4, but we stretched this twice as high, which is why we went up 8 units instead of 4 units. So my parabola looks like this. Okay, how can I take this form and rewrite it in vertex form? So the original form up there is f of x equals 2 times x minus 2 times x minus 2. I want to get it in vertex form. What is vertex form? It's when you take the letter a and you have your vertex x minus h squared plus k. Well, this isn't bad. What is my vertex? My vertex is 2, 0. So if my vertex is 2, 0, that means my h is 2 and my k is 0. So I'm going to plug that in. So I have x minus 2 squared. So I plugged in my h, I plugged in my k. And then the last thing I need to do is identify my a. Your a doesn't change. What is my a? My a is just 2. So all I'm going to do is pop that 2 in there because it has a stretch factor of 2, right? If I look at my graph, we just have a stretch factor of 2. So what can we write? It would just be f of x equals 2 times x minus 2 squared. All right, last one. Again, you might want to pause and try this on your own. We're trying to get you to connect. Can you change from vertex form to intercept form to general form? Sorry, this should say general form. So decide which one you want to go with first. I'm hoping you are going to say, well, you either go with vertex form. So what is my vertex? My vertex is right 1 down 2. So right 1 down 2. So my vertex form, I could use that, or I have x-intercepts. My x-intercepts are negative 1, 0, and 3, 0. That's going to help me with my intercept form. And then your general form should be relatively straightforward. All you're going to do is expand either your vertex form or your intercept form. So pause. Try that on your own. Okay, so I did vertex form here. My vertex is at 1, negative 2, so I'm going to have x minus h squared, so that's x minus 1 squared, and then down 2, so I have minus 2. So the only value I need to get is my letter a. Okay, how do I get my a? Well, usually it's a 1 to 1, 2 to 4, but instead of going 2 to 4, I only went 2 to 2. So what did I do? I divided that by 2, or in other words, I halved it. So my stretch factor is only 1/2. If you don't know how to get that, then you have to actually calculate it. So you'd have x minus 1 squared minus 2. Pick a point. So this point right there, 3, 0, is on the graph. So when y is 0, x is 3, and you would actually solve. 3 minus 1 is 2, 2 squared is 4, so that would be 4 times a. you would move the 2 to the other side and you would get your a to be equal to 1/2. You don't have to do the calculation, but you can. But if you can see it very clearly on the grid, then you can just do that 1 to 1, 2 to 4 relationship and see how it's impacted and insert that over here. But now that you know your a value, you can do that for intercept form as well. So your intercept form, we have an a value of 1/2, and then all we do is insert our 2 intercepts. So it's x plus 1, x minus 3. Super easy. And then what do you do for the last bit? Well, hopefully you know you are just going to expand. So x plus 1 times x minus 3, expand that first. So that's x squared minus 2x minus 3. And then you're going to distribute, so you're going to get 1/2 x squared minus x minus 3/2. I'm distributing, and distributing. So this is expected. We're hoping you can go from one form to the other, especially for our assessments. You know, could you go from general form to find the vertex and graph it? Could you go back and forth here? So we're hoping you can do that perfectly or with your equations. Again, if you have questions, please reach out to your teacher, reach out to a peer, and we want to help. Thanks. Bye.